The Chrysler Hemi engine, known by the trademark Hemi, is a series of V6 and V8 engines built by Chrysler with a hemispherical combustion chamber. Three different types of Hemi engines have been built by Chrysler for automobiles, the first from 1951 to 1958, the second from 1964 to 1971, and the third beginning in 2003. Although Chrysler is most identified with the use of Hemi as marketing term, many other auto manufacturers have incorporated similar designs. During the 1970s and 1980s, Chrysler also used the Hemi name for their Australian-made Hemi-6 engine and applied it to the four-cylinder Mitsubishi 2.6L engine installed in various North American market vehicles. Hemispherical engines. A hemispherical combustion chamber allows the valves of a 2 valves per cylinder engine to face each other across the chamber, rather than opening side by side. This layout makes space in the combustion chamber roof for larger valves and straightens the airflow passages through the cylinder head. This creates what is known as a cross-flow head, where the intake charge flows directly across the chamber to the exhaust valve located directly opposite it. Actually, a cross-flow head designates an engine that has the intake manifold on one side only, and the exhaust on the other, as opposed to both manifolds being located on the same side of the engine, or cylinder head. A cross-flow design allows the air to flow in one side and out the other, which adds efficiency and power. A reverse-flow engine requires the gases to flow in, stop, and reverse direction. A hemispherical engine spreads the valves apart and places them at an angle to decrease resistance, but it's only an improvement on a cross-flow head. These features significantly improve the engine's airflow capacity, which can result in relatively high power output from a given piston displacement. But the design can also significantly increase the flow of incompletely combusted air-fuel mixture straight out of the exhaust valve. With a Hemi combustion chamber, there is minimal quench and swirl to burn the fuel-air mix thoroughly and quickly. The spark plug is frequently placed at or near the centroid of the chamber to facilitate complete combustion. Hemispherical combustion chambers, because of their lack of quench, are more sensitive to fuel octane rating. A given compression ratio will require a higher octane rating to avoid ping in a Hemi engine than in a wedge engine. Engines with hemispherical combustion chambers often use dome-topped pistons to retain the desired compression ratio, but this design only works best at higher PM. The Hemi head usually has intake and exhaust valve stems that point in different directions, requiring a large, wide cylinder head and complex rocker arm geometry in both cam-in block and overhead cam engines. This adds to the overall width of the engine, limiting the vehicles in which it can be installed. Wwii, Chrysler developed their first experimental Hemi engine for the Republic P-47 Thunderbolt fighter aircraft. The 1422-20 engine was an inverted V16 rated at 2,500 HP. The P-47 was already in production with a Pratt & Whitney radial engine when the 1422-20 flew successfully in trials in 1945 as a possible upgrade, but the war was winding down and it did not go into production. However, the exercise gave Chrysler engineers valuable research and development experience with 2-valve Hemi combustion chamber dynamics and parameters. In addition to the aircraft engine, Chrysler and Continental worked together to develop the air-cooled AV1790-5B V12 Hemi engine used in the M47 Patton tank. FirePower OHV V8. Chrysler applied their military experience with the hemispherical combustion chamber to their first overhead valve V8 engine, released under the name FirePower, not Hemi, in 1950 for the 1951 model year. The first version of the FirePower engine had a displacement of 331 kN and produced 180 bhp. Eventually, each Chrysler division had its own versions of the FirePower engine, with different displacements and designations, and having almost no parts in common. Chrysler and Imperial called their versions the FirePower. Desoto called theirs the Fire Dome. Dodge had a smaller version, known as the Red Ram. Only Plymouth didn't have a version, instead retaining the polyhead engines. There was no Plymouth Hemi engine until the 1964 426. Collectively, the 1951-58 Hemi engines are now commonly referred to as first-generation Hemi engines, and the group can be identified by the rear-mounted distributor and the spark plugs in a row down the center of wide valve covers. Briggs Cunningham used the Chrysler version in some of his race cars for international motorsports. A Chrysler-powered Cunningham C5R won its class in 1953. Cunningham switched away from these designs in 1959 when a Chrysler abandoned the hemispherical concept in favor of a wedge-head B engine. Chrysler and Imperial, all Chrysler FirePower engines are over square. The bore is larger than the stroke. 331. This first FirePower engine, used from 1951 to 1955, has a bore of 3.8125 in and a stroke of 3.625 in for a piston displacement of 331 kN. Most used a two-barrel carburetor and produced 180 bhp, with the famous exception of the 1955 Chrysler C300 equipped with dual-cutter WCFB 4-barrel carburetors. The 331 engine was used in the following applications: 1951 a Euro 1955 Chrysler New Yorker, 1951 a Euro 1954 Chrysler Imperial and 1955 Imperial A, 1951 Chrysler Saratoga, 1952 Chrysler Saratoga Club Coupe, 1952 Chrysler Imperial Parade Phaeton, 1955 Chrysler C300, the Chrysler Air Raid Siren. At 138 decibels, it is the loudest siren ever made. 354, the 354, released in 1956, had a bore of 3.9375 in and stroke of 3.625 in. The 300B engine was rated at 340 bhp, while the New Yorker and Imperial 354 engine configuration produced 280 bhp. For the 300B an optional 355 bhp version was available, making it the first American V8 to be rated at 1 horsepower per cubic inch. Note that before 1972, horsepower was SA gross. After 1972, horsepower is SA net. The 354 was also modified. The Hemi was optimized for heavy-duty truck service. These were available with 1 or 2 4-barrel carburetors, and were offered in Dodge's heaviest-duty models as the Power Giant V8 from 1957 through 1959. They were the largest of 4 Hemi truck engines offered by Dodge in the 1950s. The 354 was also offered in certain models with polyspheric heads rather than Hemi heads. The combustion chambers on these had similarities to both Hemi and wedge heads, but were closer in weight to wedge heads. Thus, both 354 Poly and 354 Hemi V8 engines were variously available in 1957. The 354 engine was used in the following applications: 1956 Chrysler New Yorker, 1956 Chrysler 300B, 1956 Imperial Custom and Crown, 1957 Dodge D501, 1957, 1959 Dodge C-Series pickup, 392. The 392 raised deck engine released in 1957 had a 4.00 in bore and 3.906 in stroke. The deck height, at 10.87 in, was 0.5 in taller than that of the previous blocks. Because its deck was taller, the heads were cast wider so that earlier manifolds could be used with the new heads on the new taller block. For 1958, Chrysler offered the 392 in 2 configurations, 325 bhp with 9.251 compression and 345 bhp with 10.1 compression, both with a single 4-barrel carburetor. A dual 4-barrel version of the 392 available in the 1957-58 Chrysler 300C and 300D cars was rated at 375 bhp. An extremely rare option available on the 1958 300D was Bendix electrojector fuel injection, with which the 392 was rated at 390 bhp. Due to reliability problems with the primitive board computer which controlled the injection system, however, 15 of the 16 300D cars built with the fuel injection option were recalled and retrofitted with carburetors. The 392 engine was used in the following applications: 1957 to 1958 Chrysler New Yorker, 1957 to 1958 Imperial, 1957 Chrysler 300C, 1958 Chrysler 300D. In the late 1950s and early 1960s, drag racers found the 392 to be a formidable engine and continued to run them competitively into the 1970s. Desoto. Desoto's Hemi engines were called Firedome 276. In 1952, Desoto introduced its version of the FirePower with a bore of 3.625 in and stroke of 3.344 in, for a displacement of 276.1 kN. Power output was 160 bhp. It was a hot seller, with 50,000 vehicles using the engine until it was replaced in 1954. 291, an increase in displacement to 290.8 kN was made for 1955 by increasing the bore to 3.72 in, 330. The Desoto engine was enlarged for 1956 to 329.9 kN. Bore was the same as the 291 at 3.72 in, but stroke was increased to 3.80 in and a taller block was used. 341, displacement was increased again for 1956 and 1957 to 341.1 kN. Bore was now 3.78 in with stroke remaining at 3.80 in. The Desoto Adventurer produced 343 bhp using dual-cutter WCFB 4-barrel carburetor more than 1 horsepower per cubic inch. The 1956 Desoto Adventurer was the premier named high-performance version the Desoto equivalent of the Chrysler 300 using dual-cutter WCFB 4-barrel carburetors. The Adventurer engine for 1956 used a displacement of 341 cid and had a compression ratio of 9.5 to 1, using a special hydraulic camshaft profile. 345. The largest Desoto engine for 1957 was the Desoto Adventurer offering 344.6 kN with square bore and stroke dimensions of 3.80 inches. The Desoto Adventurer used dual-cutter WCFB 4-barrel carburetors for a rating of 345 bhp, again producing 1 horsepower per cubic inch utilizing a similar intake manifold to the 1956 341 Adventurer and a similar camshaft. Compression ratio remained at 9.51. Dodge's Hemi was introduced in 1953 as the Red Ram. Dodge did not have a V8 engine until one was developed specifically for the line in 1953 based on the 1951 Chrysler Hemi design, but downsized for these smaller cars. They have the smallest bore center distance of any Hemi engine at 4.1875 in. They do not share any major dimensions or components with the larger Chrysler and Desoto Hemi engines, or the Plymouth A engines. From 1955-58 lower performance versions of the Dodge Hemi were introduced by substituting less complex polyheads and valve train parts, including one variant only built as a poly. These were used in low-line 1955-58 Desotos and Dodges, and 1955-56 high-line Plymouths. 241.6, Dodge introduced the 241.6 kN engine in 1953. Bore was 3.4375 in and stroke was 3.25 in. With a low compression ratio of 7.1 to 1, the 241.6 produced 140 bhp. This engine is not the same as the Plymouth 241, which are polyspherical, not Hemi heads. 270. The D553 1955/1956 Dodge Super Red Ram Hemi 270 displaced 270 kN and was used in the 1955 and 1956 Dodge Highline vehicles. Bore was 3.625 in and stroke was 3.25 in. It was not the same as the 270 polyhead. In the Dodge Coronet, running 7.6 to 1 compression ratio, the 270 produced 183 bhp. In higher trims like the Dodge Meadowbrook, it ran a 7.6 to 1 compression ratio and with a 4-barrel carburetor produced 193 bhp. 315, for 1956, Dodge increased the displacement to 315 kN with a longer 3.80 in stroke and a taller raised deck block and now with a polyspherical heads no longer a Hemi. but the optional high-performance D500 version of this engine had a 4-barrel carburetor and a larger valve Dodge hemispherical combustion chambered head. Also, a race-only package called the D500-1 or -1 was available with a special aluminum dual 4-barrel intake that sported a pair of Carter WCFB carburetors similar to the ones on the Chrysler 300B and Desoto Adventurer. This engine utilized the same cylinders heads as the base D500 model. 325, Dodge released a 325 Acclaim engine for 1957. The engine used a 3.6875 in bore and 3.80 in stroke. The base engine offering was now a polyspheric chambered head referenced as KDS, and a higher performance 325 was offered with Hemi heads as the KD500. Again there was a low-volume offering of the KD500-1 with dual 4-barrel carburetors. All engines now, however, had hydraulic camshafts even though the Hemi-headed offerings sported dimples in the valve covers for mechanical adjuster clearance. 426, the Elephant, the hemispherical head design was revived in 1964. These were the first engines officially designated Hemi, a name Chrysler trademarked. Chrysler Hemi engines of this generation displaced 426 Acclaim. Just 11,000 Hemi engines were ultimately produced for consumer sale due to their relatively high cost and the sheer size of the engine bay required to fit it in. The 426 Hemi was nicknamed the Elephant engine at the time, a reference to its heavyweight and large outer dimensions. Its 10.72 in deck height and 4.80 in bore spacing made it the biggest engine in racing at the time. The 426 Hemi of the 1960s was an engine produced for use in NASCAR, used in a racing version of a Plymouth Belvedere in 1964. It was not initially available to the general buying public. The 426 Hemi was not allowed to compete in NASCAR's 1965 season due to its unavailability in production vehicles sold to the general public. Chrysler introduced the Street Hemi in 1966 for its intermediate range of cars and sold the required number of Hemi engines to the public to legitimize its use for NASCAR in 1966. Although all manufacturers were familiar with multi-valve engines and hemispherical combustion chambers, adding more valves per cylinder, or designing the complex valve train needed for a hemispherical chamber, were expensive ways of improving the high RPM breathing of production vehicles. By counting the angle of the NASCAR mandate to 2 valves per cylinder, significantly larger valves could be used. The Chrysler Hemi had an over-square 4.25 inches bore and 3.75 in stroke as did the wedge-chambered big block Chrysler AB. The 426 Hemi also was used in NHRA drag racing. Its large casting allowed the engine to be overbid and stroke to displacements unattainable in the other engines of the day. Top Fuel Racing organizers limited the bore spacing of engines until very recently, when under pressure from Ford and other manufacturers, the bore spacing allowed was increased to 4.900 inches a year. This allows other engines such as the Ford 385 series to begin to compete. The engines based on the old Chrysler design predominate top fuel and funny car classes due to plentiful parts, large amount of research and development, as well as decades of experience with the problems of the engine's design. In NHRA top fuel racing today, the engine bears little resemblance to any engine produced by Chrysler. It is usually equipped with a large Roots-type supercharger and short individual exhaust pipes, and fueled with nitromethane. The 426 Hemi, in Street Hemi form, was produced for consumer automobiles from 1965 through 1971. There were many differences between the Hemi and the wedge-head big block, including cross-bolted main bearing caps and a different head bolt pattern. There were also many differences between the racing Hemis and the Street Hemi, including but not limited to compression ratio, camshaft, intake manifold, exhaust manifold. Some 1960s NASCAR and NHRA Hemi engines featured magnesium cross-ram intake manifolds and magnesium oil pans in an attempt to reduce the massive weight of the overall engine, along with chain-driven internal dry sump oil systems. Today, aftermarket blocks, heads, intakes, rods and pistons are usually made of aluminum. The Street Hemi version was rated at 425 bhp, gross, with 2 Carter AFB carburetors. In actual dynamometer testing, it produced 433.5 horsepower and 472 lb-aft torque in purely stock form. Interestingly, Chrysler's sales literature published both the gross 425 HP and net 350 HP ratings for 1971. To avoid confusion with earlier and current Hemi engines, the 426-based Hemi is sometimes called the 2G, or Gen 2 Hemi. The street version of the 2G Hemi engine was used in the following vehicles: 1966 a Euro 1970 Dodge Coronet Plymouth Belvedere, 1966 a Euro 1971 Plymouth Satellite, 1966 a Euro 1971 Dodge Charger, 1967 a Euro 1971 Plymouth GTX, 1968 Dodge Dart, was not street legal. 1968 Plymouth Barracuda, 1968 a Euro 1971 Dodge Super B, 1968 a Euro 1971 Plymouth Roadrunner, 1969 Dodge Charger Daytona, 1970 Plymouth Superbird, 1970 a Euro 1971 Plymouth Barracuda, 1970 a Euro 1971 Dodge Challenger, 1970 Monteverdi High 450, modern Hemi. The current production HEMI engine heads are flatter and more complex than the 1950s or Euro 70s Hemi V8 chamber. The chambers are no longer truly hemispherical. It uses a coil-on-plug distributorless ignition system and 2 spark plugs per cylinder to shorten flame travel, leading to more consistent combustion, which helps reduce emissions. Like most of Chrysler's past model Hemi head engines, the 5.7 version is rated at approximately 1 horsepower per cubic inch. For the 2009 model year, power has been bumped up to 357 to 390 horsepower and 389-410 lb-aft depending on application. It also achieves 4% better fuel economy. Variable valve timing was also introduced. A new variable displacement technology called multi-displacement system is used in some versions, which can shut off 2 cylinders on each bank under light load to improve fuel economy. 5.7. The 5.7 L Hemi was released for model year 2003 on the Dodge Ram 1500, 2500, and 3500 pickup trucks to replace the Magnum 5.9 engine. It also replaced the 8.0 L V10 engine in the heavy-duty Ram. As of 2004, it was the only available gasoline engine in the Ram heavy-duty. Chrysler later made the 5.7 L Hemi available in all models of the 2004 Dodge Ram, Dodge Durango, the 2005 Chrysler 300C, Dodge Magnum RT, Jeep Grand Cherokee, the 2006 Dodge Charger RT, and the 2009 Dodge Challenger RT. For the Challenger, the 6-speed version does not feature MDS. The 5.7 L Hemi in the Ram delivered 345 HP and 398 lb-aft, but 340 HP and 390 lb-aft for the 300C and Magnum RT, which is exactly 100 HP more than the old 5.9 engine. It is a 90-degree V8, 2-valve pushrod design like the past MB engines, displacing 5,654 cc, with a bore of 3.917 in and a stroke of 3.578 in. The 5.7 L Hemi is made at Chrysler's Saltillo engine plant in Ramos Arizpe, Mexico. The Hemi was on the Ward's 10 Best Engines list for 2003 through 2007, and again in 2009. This engine is used in the following vehicles: 2003 a Euro present Dodge Ram, 2004 a Euro 2009, 2011 a Euro present Dodge Durango, 2005 a Euro present Chrysler 300-300C, 2005 a Euro 2008 Dodge Magnum RT, 2005 a Euro present Dodge Charger RT, 2005 a Euro present Jeep Grand Cherokee, 2006 a Euro 2010 Jeep Commander, 2007 a Euro 2009 Chrysler Aspen, 2009 a Euro present Dodge Challenger, Dodge Durango RT, 2009 revisions. Chrysler has made various revisions to the 5.7 L for the 2009 model year. The first for all applications is what Chrysler calls variable camshaft timing, or VCT. VCT uses an oil control valve which controls oil flow to a unique camshaft sprocket which contains a phasing device, which depending on the operation of the oil control valve either advances or retards camshaft timing. Cylinder heads have been revised to increase flow. Though the intake manifold has also been changed on all applications, it is however model-specific. Dodge Ram, non-hybrid electric vehicle Chrysler Uspens, and non-HEV Dodge Durango utilize an active intake manifold with a short runner valve to optimize torque and horsepower. At lower engine RPM the valve is closed, resulting in improved low-end torque from the longer runners. At higher engine RPM the valve is opened, diverting the incoming air into the center of the manifold. The shorter runners results in improved horsepower. Passenger cars, Jeep vehicles, as well as HEV Chrysler Aspen and HEV Dodge Durango do not use this manifold. These vehicles utilize a passive intake manifold, which does not have a short runner valve. 6-speed manual transmission and all heavy-duty truck applications will differ by not having the multi-displacement system. The new version of the 5.7L has 5 different camshaft profiles. All will have VCT. Active intake with MDS, active intake without MDS, passive intake with MDS, passive intake without MDS, HEV application, 2011 plus power numbers, 300C, 363 HP, 394 lb-ft, charger AT, 370 HP, 395 lb-ft, Challenger AT 5-speed automatic, 372 HP, 400 lb-ft, Challenger AT 6-speed manual, 375 HP, 410 lb-ft, Ram 1500 truck, 390 HP, 407 lb-ft, 2013 plus Ram 1500 truck, 395 HP, 407 lb-ft, Jeep Grand Cherokee and Jeep Commander, 360 HP, 390 lb-ft Dodge Durango, 360 HP, 390 lb-ft, 6.1. The Hemi is also available in a 6059 cc version. The engine's bore is 4.06 inches, and many other changes were made to allow it to produce 425 HP at 6200 rpm and 420 pound-force-feet of torque at 4800 rpm. The engine block is different from the 5.7, with revised coolant channels and oil jets to cool the pistons. A forged crankshaft, lighter pistons, and strengthened connecting rods add durability. A cast aluminum intake manifold is tuned for high RPM power and does not include variable length technology. Chrysler's multi-displacement system is not used on the 6.1. Applications: 2005 a Euro 2010 Chrysler 300 CS Euro 8, 2005 a Euro 2008 Dodge Magnum SRT8, 2006 a Euro 2010 Dodge Charger SRT8, 2006 a Euro 2010 Jeep Grand Cherokee SRT8, 2008 a Euro 2010 Dodge Challenger SRT8, 6.4/392. Chrysler displayed a larger 392 cubic inch Hemi in 2005 with output 525 HP and 510 lb-ft torque. It is based on an iron 6.1L engine block with aluminium alloy pistons. This engine has been available since 2007, as a crate under the name 392 Hemi. The production version of the 392 Hemi was launched in the 2011 Dodge Challenger SRT8 with variable camshaft timing as well as MDS in cars with automatic transmissions. The new 392 Hemi, codenamed Apache, is based on the third-generation 5.7L Hemi, codenamed Eagle, and shares few parts with the 392 crate engine. In late 2009 Chrysler has said the new engine will be available in the next-generation SRT8 Dodge Charger, Chrysler 300C, and Jeep Grand Cherokee. Special edition Challengers equipped with this engine, and the engines themselves, will bear 392 HEMI badging in commemorative reference to the first-generation Hemi engine of the same piston displacement. In other applications, the engine is badged as 6.4L Hemi. It is much more similar to the revised 5.7L V8 Hemi that was released in 2009 and is a completely different block and build than the 392 crate engine. Outputs is 470 HP and 470 lb-aft. Availability of the 6.4 is to expand to the Chrysler 300 SRT8, Dodge Charger SRT8, the Ram 2500 and 3500 trucks, and the Jeep Grand Cherokee SRT8. Mopar 426 HEMI. At the 2012 North American International Auto Show in Detroit, Dodge debuted a Mopar customized Dodge Charger redesign that featured a modern 426 cubic inch HEMI V8 engine rated at 590 HP. Marketing. During February to April 2005, Daimler Chrysler hosted a "What Can You HEMI?" contest promoting alternative uses of the HEMI engines. The top 5 finalists include HEMI Snowblower, HEMI Go Round Carousel, HEMI On Ice Ice Resurfacer, HEMI Shredder, HEMI Big Wheel, that is the child's tricycle of the 1970s. The winner was the HEMI Big Wheel, which had a 5.7L HEMI in the back that was installed backwards, thus reverse became the only forward gear. Plate steel was the predominant material, while a roll tube of steel had to be utilized for the front tire as there were no such tires 4 foot in diameter that were as narrow as needed for this project. As collector items, Dodge and Plymouth Hemi-powered cars produced between the model years of 1965 and 1971 have become collector's items. References. Notes. Note: Imperial became a separate make and division starting in 1955 and no longer bore the Chrysler name. External links: How a Hemi engine works, new Hemi technical article at Auto Speed, the original HEMI, Mopar HEMI Gen 2 page, Mopar HEMI Gen 3 page, 1.